This content is brought to you by Mazunder Academy.
Hello everyone. In this lecture we are going to see data visualizations in R. So as per the course requirement, we will study histogram, frequency polygon and ogive. Pie chart and bar plot we will not cover in this lecture, and box plot we will cover in another lecture. So let us start the demonstration. For the demonstration purpose, we will use our inbuilt dataset at the beginning. CO2 is a dataset in R which we will use, and if we see the CO2 dataset, so the code is view CO2. So if you run view CO2, then we can see on the screen there are 5 columns: plant type, treatment, concentration and uptake. So here we are considering uptake for our drawing purpose. As we know, histogram, frequency polygon, ogive, these all require numerical data. So we will use uptake data to demonstrate how to draw histogram. So if we see, we have a code here attach. So attach CO2. If we run this, what it will do, this CO2 dataset will be attached to the environment, and as a result, all the columns of CO2 will be available to us to use directly. So let us run. Now hist is the function which will be used to draw histogram. So the code will come like hist, and then uptake is the data, and if you run, we will get the histogram. Remember, this histogram is drawn as per the number of classes decided by the program. It is not user defined number of classes, and if you want to know how to draw a histogram based on the user defined number of classes, then I have a separate lecture on it. But here in this lecture we are considering whatever the number of classes the system will assign, that number of classes we will consider, and we will draw the histogram, frequency polygon and ogive. This is the default one. Next I am going to show some of the decorations on this histogram, and these decorations may be same and similar to other graphs. So I will just cover here. For example, if we want to give different colors, so we can see there is a object called color, so we can assign different colors. You can assign here inside a vector different own self determined colors like red, green, blue, or easy way is there is a rainbow color. So rainbow, 7 different colors are available, so alternatively it will take and it will color the bars. If I run it, we can see, so rainbow colors used to color, so 7 colors you can count here up to here, and again it started repeating the colors. We have total 9 bars here, and I assigned 7 colors of rainbow, so 7 colors will be used here, and then again it will start repeating the same set of colors. If I want to see the border of these bars with a different color, then I can add this border equal to my own defined color. For example, I am defining border equal to blue. So if I add border equal to blue in this, then you can see this borders changed to blue now. Or if the blue is not much visible, it's visible, I think. Or if you want to change, say for example, make it some other color, red, and if you run, you can see it is little much visible. Now next parameter that I want to add in hist function, that is, suppose I want to shade this by lines. Each bars I want to shade using lines, not filling colors. If you want to do, then that is called density. So if you add the parameter density, then it will shed all these bars using lines. So you can see here, if you put this parameter density equal to 5, then it will work like this. So we can see each colors used, and instead of filling completely, it is doing lines. So this 5, if we make it 3, you can see it will use little less number of colors. If you use more, say 6, it will take little more number of lines, and so on. Now if we want to change these colors, like for example the color of this axis, it is by default black color. Uptake has come out using black color, and frequency black color, then name black color. If you want to change those colors, so you can mention here the parameter col dot axis. Some color you defined here, it is blue, so axis colors will be blue. Then if you use col dot lab, okay, it is red. Then col dot main, that means histogram of uptake, so this information will be changed to yellow color. So if we run this code now, let us see how it is changing. So we can see uptake frequency, this is red because of color dot level equal to red, and this color dot axis equal to blue. Because of that, this axis that mentioning, that is class boundaries, these all class boundaries and the frequencies on the axis, that will be blue, because blue we have assigned here. Similarly, sometime as our requirement, we may need to do this writing, I mean this class boundary vertical or horizontal. So there is a parameter called LAS. So last parameter, if we mention 1, if I run it, you can see, so this is by default, okay, so normal. If you do not mention LAS, then also it will remain same. But if you keep on changing, for example, it takes value from 0, 1, 2 and 3. So if you put 0, so you can see what changes will happen, and run it. So this will be towards like perpendicular to the axis. So x-axis along the direction is horizontal, and y-axis along vertical. Just understand how it will affect, and already 1 I have shown you. So if I put 2, then you can see how it will affect. So if it is 2, then x-axis will be vertical, y-axis will be horizontal. And if you put 3, then you can see both x-axis and y-axis both vertical. So this is the way you can do some decorations. Now sometimes it may be requirement that the borders you need to be made little bigger in size. So for that, what we have to do, there is a function called PAR, and LWD is the line width. So if you give, say for example, it is 3, 5 will be much bigger. And remember, this PAR function, you have to run it before histogram. So let us run this PAR before histogram, and then if you run hist function, then you can see the changes happening here. All the lines which is used for drawing histogram, these all lines, I mean all the lines of the bars are bigger in size now. Okay, thickness has been increased. If you change it to 5, you can see it will be little much bigger. So histogram, if you run, so we can observe it in the output. So this is some of the decorations that I mentioned here. Now I will take a fixed data, like the data which is supplied in the question. So this set of data I will use to demonstrate histogram, frequency polygon and ogive. You can try by seeing my rest of the lecture. You can try how to draw the histogram here for uptake data, how to draw frequency polygon, how to draw ogive. But right now already I have demonstrated how can we use our inbuilt data set to draw histogram. Now I am using fixed data to draw histogram. So when you have data supplied with the question, like here, the first work is you have to store the data in a variable. So as I have seen here, the structure of the data, but remember it is not necessary always that you will have the same structure, and the best option is you just copy the data and paste here inside the vector C separated by comma. Otherwise, in this question I have observed that data have some sort of special characteristics. I mean, you can see the data, first data starting from 3 up to 12. So I can use this colon operator to define this all data. So my starting is 3 and up to 12. So it will take 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After that I have seen again 6, 7, 8. So I have taken another set of data 6 to 8 using colon operator. Then 6 and 7. So I have taken 6 colon 7. You can do 6 comma 7 also here because only 2 data. And last one is 9. So 9 is added. So this piece of code, what it will do? It will store this data in the variable D. So if I run, I can see D is created, and if I want to see the output whether really D is created or not, so just type D and control enter. So you can see yes, all the data stored in D is the data given in my question. So I don't need this. Now hist is the function, as already I have seen in earlier example. So hist is the function, D is my data, so it will create histogram, and COL is the color object where I am using rainbow color. If I run this, we can see this is the histogram, and this color, dark color, is coming a little bigger in size because of that PAR function. If I remove this PAR function from here and if I run it here, we can see the histogram. It will be the normal histogram with different 5 rainbow colors. Now up to this it is clear to us. Now h is a variable where I am storing the output of this hist function for my future use. Let me see what are the content inside this h, and moreover if we see here mentioned h is a variable where we have stored, it is a list of 6 items. Let us see what is there available in h. So inside h, if you put h then dollar, you can see it has breaks, it has count, it has density, it has mids, it has x name, it has equidistance. So these are the 6 quantities available inside this variable h. Now what are that? So if I run this h, we can see here inside h, breaks contains all the class boundaries that is used here. You can see 2, 4, 6, 8, 10 and 12. So these are the different class boundaries, and how many classes used here? 1, 2, 3, 4, 5 different classes used. So system assigned, okay, whatever system assigned, that will further proceed with that. Then count. Inside H, the count contains all the frequencies. So 2, 4, 5, then 3, then 2. So these are the different frequencies. So now onwards, remember, breaks contains your all class boundaries, count contains your frequencies. Density at this moment we don't need. Mids, very important, midpoints. So if we see what will be the midpoint of this class 2 to 4, midpoint will be 3. 2 plus 4 divided by 2, it will be 3. Next midpoint will be 4 plus 6 divided by 2, it is 5. Next midpoint 6 plus 8 divided by 2, it's midpoint 7. So the midpoint of 8 and 10, 9. When midpoint of 10 and 12, it is 11. So these all are the midpoints of the classes. And remaining informations we don't need at this moment. So we will remove this histogram over. We will go for a frequency polygon, and before that I am leaving those decorations, border, colors, other things all, okay, assigning the borders, assigning different shadings and all, everything which I already explained earlier. So you can explore it further. There are many more parameters of hist function which you can explore. So if we see the theory of this, so histograms is a graph between class boundaries and frequencies. Along y-axis frequency, along x-axis class boundary. So which is very clear. Now for frequency polygon, if we see along x-axis midpoint and along y-axis frequency. So right now midpoint is available for me in hist, I mean H dollar mids. But remember one point, in the midpoint you can see here, if as in this example, the midpoint, first midpoint is 8 and the last midpoint is 33. But in the diagram you can see there are extra midpoints, 3 and 38 are taken, and both of their frequency is 0. So these two extra midpoint we need to take just to make the polygon closed, because polygon is a closed graph. So we have to close it so that it will become a polygon. So in practical also we have to take these two extra midpoint. One is below and another one is above with frequency 0 for both. So this is an important point that we need to keep in mind. So as we have seen, H breaks, inside H breaks we have all the class boundaries, inside H counts we have all the frequencies, and inside H mids we have all the midpoints. So first let us make the midpoints, that including extra 2 points. Now if I run this H mids for the requirements, you can see H mids right now the lowest mid value is 3 and the highest mid value is 11. And what is the gap? 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. 9 plus 2, 11. So 11 plus 2 will be 13. So my next midpoint will be 13. Midpoint which is at the lower side, that will be 1. Because 3 minus 2 is 1. So if I run this and if I want to see the mids, it's really working or not. So we can see here the mids are 1, 3, 5, 7, 9, 11 and 13. So 13 and 1, these are the two extra midpoints I have taken whose frequencies will be 0. So that also 0 frequency is not available in your counts. If we see H dollar counts, we have frequencies only 2, 4, 5, 3 and 2. So this extra 0 in the upper side and 0 at the lower side, we have to include them. We have to concatenate and append them at the end and at the beginning. So that works. How can we do? Say FREQ, freq is the variable where we are storing the new frequencies along with the extra 0 at the lower side and extra 0 at the upper side, and in between the actual frequencies which is available in $H count. So if I run it and if I want to see FREQ run, so we can see here the freq variable have all the frequencies including that lower side 0 and upper side 0. So now my frequencies are ready and midpoints are also ready. Now it is time to draw the frequency polygon. So as frequency polygon is a graph I have shown just now, it is a graph between midpoint along x-axis and y-axis frequencies. So we will apply the function plot, and along x-axis mids, this data mids data will be used in along x-axis, and freq data, that is the new frequencies including zeros, that will be in y-axis. So if I just run up to this, then we can see what will happen. We can see the only it is showing the points without any line. So if I want this line, then what we have to do? We have to add another parameter, type equal to b. B means both. Both means point as well as line. And then color, as you know, you can use rainbow color or you can use any fixed color. I'm using it blue color here. And this type is the important parameter. Type will be representing I want point as well as line in between the point. So if I run it, we can see it will be drawing the frequency polygon here. So the rest, this width of this line, then color, then plotting character. Okay, if you don't like this hollow circle, you can make it dark circle, you can make it star, or you can give some other character. You can make these values visible here. So different things we can do. Moreover, in histogram I forgot to mention something. If we want to see the levels here, say levels right now not showing here, so if I want that my levels also should be shown here, so there is a property called levels equal to true. So if you put levels equal to true, you can see this all frequencies will be showing here. So all the frequencies will be available here. Similarly, you can try here also. Now I will go for Ogive. Now Ogive is a graph. If I show you in theory, Ogive is a graph between class boundaries which is ready with me and cumulative frequency, class boundary along x-axis and cumulative frequency along y-axis. So cumulative frequency right now it is not ready, I have to make it ready. And one point I want to mention here, you can see when you will calculate the cumulative frequency, you can see this 3 is the first cumulative frequency which is placed against the upper limit of the first class interval. So 10.5, you can see here 10.5 against 10.5, the frequency 3. Similarly, 9 will be placed against the upper limit 15.5. So 15.5 against this 9. But you can see in the diagram that the first, that is the lower limit of the first class, its against frequency is 0 because you have to close the graph with 0. So this 0 is not available in the cumulative frequency, it will not come. So that point we have to add while creating cumulative frequency. So we have to keep it in mind. So go to the demonstration. So first actual frequencies I have in H dollar count, and this extra 0 I am making it extra frequency 0 is included at the beginning, because I already told just to place this frequency against the lower limit of the first class. So F1, if you run this and if you want to see this F1, you can see here. So F1 is what? 24532. These are the frequencies, actual frequencies, and this is the extra frequency 0 taken just to close the ogive. Then there is a function called CumSum, cumulative summation. CumSum is the function which can give me the cumulative summation of the frequencies. So if I apply CumSum over F1, and the result if I store in a variable that is called csum or something, then if you run and just to see, if you run this variable, so you can see 0, 2, 6, 11, 14 and 16. So if you do the cumulative summation, first one is 0, second one is 0 plus 2 is 2, 2 plus 4 is 6, 6 plus 5 is 11, 11 plus 3 is 14, 14 plus 2 is 16. So cumulative summation is available in csum variable, and of course I have h breaks is the class boundaries 2, 4, 6, this all. So I can draw the graph using plot function. X-axis, it will be the class boundaries which is available in h breaks, then y-axis is CumSum, cumulative summation. So if I just close here, or separately if I show you just up to this, if you run it, you can see here these are the point of ogive, but there is no line. Okay, that can be managed using type. So the next code, it including the complete code, like x-axis is the class boundary, y-axis is the cumulative summation, and type equal to b. B means both line and point, color equal to red. X level, you can see by default it is giving h dollar breaks, which I am not happy with this. So I want like class boundaries should come here in x-axis, so I can give xlab. Xlab is the parameter. If I add, then whatever I will mention here within the double quotes, it will appear here. Similarly, ylab, csum, it is coming by default, the variable csum, its name will come, but I want some, say, cumulative frequencies or something I want to appear, I want the graph should appear here. Then there is no name by default, or if name comes, it will be some other name. But if you want to give your own name, then you can use it main equal to some name, whatever you want to give. So I have given ogive. Now if I run it, you can see as required, as I have preferred, everything is appearing here. So that completes my ogive. Now the rest, line width, then plotting character and other decorations, you can try at your own. So that's all for ogive, frequency polygon and histogram. So thank you so much.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.